I am going to explain the CHORUS project. Our objective is to predict the electrical energy output of combined cycle power plant. I am going to answer every question. The first one, define the type of machine learning and select an appropriate output metric. Because we need to predict a specific numerical value, we select regression type and we select regression error metric as a output metric, especially mean square error because it is the most common use in these cases. The second one, identify the algorithm. We graphed each variable against the output and we can see there is a linear relationship. Therefore, we select linear regression algorithm. As we see, we bring the data and we graph every variable against the output and we can see that there is a linear relation in every variable. The next question is determine the feature. Based on extensive review, technical review, doing analysis, domain expertise, we can see that all of the features are a great impact and frequency inclusion very high. So we can use the four of them. The next analysis is statistic correlation. We use correlation analysis for each variable, specifically correlation coefficient and coefficient of determination. We decided to select features that have a correlation greater than 50% and determination greater than 25%. As we see, for every variable, we run a correlation and determination, and we see that most of the variable has a correlation above 50% and a determination above 25%. The only one that it's below is a relative humidity. So, in conclusion, given that the four are used by experts in the field and all have a clear relationship, and only one has low correlation in statistic, we decided to use two different combination of features. Combination one that have three without relative humidity, and combination two that has the four of them. The next question is split your data to evaluate and compare model. We use CAP-fold cross-validation as a validation strategy to compare the same algorithm with different combination of features. I divided the data into 5 folds, 85% of the data for training and setting aside 15% for the test set. We divided the data as we see. The test set 20% in this size, the training set 85% in this size, and every fold in this size, every fold with a training set of 80% this size, and validation set of 20% of this size. I have this tab for every iteration, and for every iteration I am going to explain one. We have the data, we run the regression for 4 features and we have the information here, and they run the regression for 3 features and we have the data of coefficient here. We create the model, the equation with here with the coefficients, and for the 3 feature the same with the 3 feature we create the equation with the data of the coefficient in the regression. Then we use the validation set that is in the yellow. We generate the prediction with the coefficients, and we generate the square error for every prediction, and finally we do the mean square error, the sum of the square error divided by the number of prediction, and we have the mean error for 4 feature model and for 3 feature model. We do the same on every iteration for the 5 folds, and we see another iteration. And for the validation we do the same and generate for the mean square error in every iteration. We come for the validation, we bring every mean square error for the iteration, and we generate the average error for both models, and we see that the minimum error is for the model of 4 features. So the next question is select the model with the best performance. The minimal error corresponds to the model with 4 features that we call combination 2. So we select this model. And the last question is evaluate the performance of your final model. We evaluate our model with the test set and notice that we have an excellent model. We have an error rate less than 1%. In most of the file, an error below 5% is considered high precision, and determination of 93%, understanding that above 90% in the field of energy and physics, such energy prediction in power plant is considered excellent. So for the final, we take here the test set, we create the linear regression with all the data that we have, and we run the regression. We have the final coefficient and the intersection. We create the equation, and we create the mean square error that we have here with all the test set, and we create the mean square error. We root mean square error of 4.41 and the target output average, and the final error that is divide the root mean square error divided by the target audience output average. We have less than 1%, and the percentage of variability is 93%. Thank you very much.